cowdung batteries you need cowdung, 1 lump cowdung, water, salt, tamarind, 1/4 of the size of the cowdung, some old cans. These cans are made of aluminium. Some old batteries, 4 used old batteries in order to make 4 batteries. First we have to mix cowdung, salt and tamarind all together into the can. Add water in order to make it creamy. Take out the carbon rod from the batteries. Insert the carbon rod into the mixture. Add wires. Here the carbon rod becomes positive and the can becomes the negative. The dung contains amines and some organic acids like uric acid. The can we are using is actually made of aluminium. Salt, as we know, it's NaCl. Tamarind is this thing which I don't want you to remember. It's just an organic acid. So we can easily say the pH of our mixture is less than 7, which is a fancy way of saying that our mixture is acidic. Aluminium has these 3 loosely bound electrons, which means it tends to lose these electrons. And so it does it here. It leaves its 3 electrons in the aluminium foil and then comes out as Al3+ into the mixture. And like this, a huge number of Al3+ comes out, leaving its electrons in it, and so that the can has much more electron density, or in other words we can say it becomes negative. And as we know, in H2O, NaCl breaks apart into Na and Cl minus, and so there are many ions, chlorine ions, available for aluminium to capture to make a stable compound called AlCl3, aluminium chloride, which is very stable with 6H2O, but that's a different issue. When I said our mixture is acidic, it meant there are lots of H+ ions loitering here and there into our mixture. This H+ ions takes out the electrons from the carbon rod, making the carbon rod more positive in nature. So the electron density this time decreases. As I have said, our carbon rod becomes positive. So now we have this positive carbon rod and the negative can. So when we connect them with wires, the electrons from the aluminium can comes to the positive carbon rod, and so there is a flow of electrons. If we have n number of batteries, every battery having EMF E and internal resistance smaller, and if the resistance of the wire is bigger, then for the parallel connection we can write for an expression for the current, which is this thing, which is pretty different from series connection. There's a reason why I am showing you this. As we know that for our battery, of course, the internal resistance is much bigger than the resistance of the wires. Thus, deducing from those expressions, we can see that in serial we are getting the electricity E by R, which actually do not depend on N, the number of batteries. But in parallel connection, it actually depends on N. So if we have more than one battery, we will of course have a better result in parallel connection. To see how to improve the battery, you have to wait for our next video.